Mexico stretches across landscapes so varied and surreal that the country seems less like a single nation and more like an entire continent compressed into extraordinary beauty. From the northern deserts, where ancient stone formations rise like silent sentinels, to the lush jungles of the south, where pyramids emerge from emerald canopies, this land holds secrets written in stone, water, and light. The geological wonders and archaeological treasures scattered throughout Mexico tell stories that span millions of years, connecting the deep time of Earth's formation with the sophisticated civilizations that recognize the sacred in every mountain, cenote, and sky. Walking through these places means moving through layers of time. The same water that carved limestone caverns over millennia also quenched the thirst of Maya pilgrims. The volcanic soil that produces brilliant hues in salt flats and mineral springs once flowed as molten rock from the planet's core. Every color, every formation, every weathered stone carries meaning that goes far beyond mere aesthetics. The people who have called this land home understood something fundamental about the relationship between earth and sky, between the seen and unseen worlds. Their cities aligned with celestial movements. Their sacred sites followed the contours of natural wonders. They didn't impose order on nature, but rather found the order already present and built accordingly. The Bacalar Lagoon stretches through southern Quintana Roo like a painter's meditation on the color blue. Local people call it the Lagoon of Seven Colors. Though anyone who spends time watching the water will tell you that seven hardly begins to capture the range of hues that shift across its surface throughout the day. The lagoon extends roughly 40 kilometers in length, a shallow freshwater body connected to the Caribbean through a series of channels, but separated enough to maintain its own character. What makes Bacalar so visually arresting isn't just the clarity of the water, but the way different depths, different compositions of the limestone bed below, and different angles of sunlight create distinct zones of color that seem almost painted rather than natural. Stand at the edge where the water barely covers your ankles, and you'll see a pale turquoise so light it's nearly white, as if someone mixed the smallest drop of blue paint into pure crystal. So walk deeper, and the color intensifies into what might be called robin's egg blue, bright and optimistic. Continue out, and you'll pass through bands of cerulean, azure, deep sapphire, and finally into sections where the water takes on such a dark navy hue it appears almost black. These transitions aren't gradual but defined, creating visible lines where one color zone meets another. From above, from a boat or one of the wooden docks that extend into the lagoon, the effect is otherworldly. The water looks striped, as if different liquids of varying densities have somehow maintained separation despite flowing together. The secret behind this chromatic display lies partly in depth and partly in composition. The lagoon bed consists of white limestone, sand, and rocks, which reflect sunlight differently depending on how far beneath the surface they lie. Where the water is shallow, more light bounces back, creating lighter tones. Where it deepens into channels and sinkholes, less light returns, producing those profound navy and indigo shades. But there's more to it than simple physics. The lagoon also hosts stromatolites, ancient formations created by cyanobacteria that rank among the oldest life forms on Earth. These rock-like structures, which can be thousands of years old, cluster in certain areas of the lagoon, their presence subtly altering the mineral content and thus the way light behaves in the water around them. Stromatolites represent one of the planet's earliest experiments in life. The bacteria that build them photosynthesize, entrapping sediment and precipitating calcium carbonate in layers that slowly, over centuries, create solid formations. Billions of years ago, stromatolites dominated Earth's waters and were responsible for oxygenating the atmosphere, making possible all the complex life that followed. Today they're rare, surviving in only a few locations worldwide where conditions remain just right. Bacalar provides one such sanctuary. Swimming near these ancient formations feels like floating in prehistory, surrounded by living links to the planet's primordial ocean. The water itself is so clear that when you float on the surface, you can watch fish moving below as if viewing them through glass. There's a stillness to Bacalar, despite the flow of water through it, a sense of peace that seems to emanate from the lagoon itself. The early morning is perhaps the most magical time, when mist rises from the water's surface and the colors soften in the gentle light. The surrounding jungle awakens with bird calls, and the lagoon reflects the pastel sky in its lighter sections while maintaining its mysterious darkness in the deeper channels. Local communities have lived along these shores for centuries, fishing and farming, understanding the lagoon as both provider and sacred space. The Maya, who populated this region long before European contact, recognized Bacalar as significant. The name itself likely derives from Maya words, possibly referring to reeds or to the concept of surrounding or encircling. Archaeological sites dot the area around the lagoon, and the colonial fort that now stands in the town of Bacalar was built atop earlier structures. The lagoon served as an important trade route connecting inland communities to the coast. Canoes laden with cacao, honey, jade, and obsidian traveled these waters, and the people who paddled them knew every current, every deep spot, every place where the colors shifted most dramatically. In recent years, as travelers have discovered Bacalar's extraordinary beauty, efforts have intensified to protect this fragile ecosystem. The stromatolites are particularly vulnerable to damage from boat propellers and from chemicals like sunscreen that wash off swimmers' skin. Local guides now educate visitors about the ancient formations and the importance of interacting respectfully with the lagoon. There's growing awareness that places of such natural wonder require stewardship, that the privilege of experiencing these colors comes with responsibility to ensure they persist for future generations. Communities around the lagoon are working to balance the economic benefits of tourism with the imperative to preserve what makes Bacalar special in the first place. Travel westward into Oaxaca, and the landscape transforms entirely. The state encompasses mountain ranges, valleys, coastal lowlands, and cloud forests, creating one of Mexico's most biodiverse regions. It's also home to some of the country's most distinctive indigenous cultures, with 16 officially recognized ethnic groups maintaining languages, traditions, and worldviews that predate the Spanish conquest by millennia. In this land of incredible cultural and biological diversity, natural wonders abound. But few are as visually striking as Hierve el Agua, a site where mineral-rich springs have created formations that defy casual explanation. Approaching Hierve el Agua involves a journey through mountainous terrain, past valleys planted with agave for mezcal production, through small villages where Zapotec remains the primary language. The site sits at roughly 1,700 meters above sea level, with sweeping views across the valley below. But what captures attention immediately isn't the vista, but the formations themselves, massive cascades of white and pale yellow rock that look exactly like frozen waterfalls. They tumble down the cliff face in ripples and waves, catching light and shadow in their textured surfaces, appearing so much like flowing water caught mid-motion that the mind struggles to reconcile what the eyes see with what logic insists must be true. These aren't waterfalls in the conventional sense, though water is responsible for their creation. The springs at Hierve el Agua are heavily saturated with calcium carbonate and other minerals. As the water emerges from underground sources and flows over the cliff edge, it releases carbon dioxide, causing the dissolved minerals to precipitate out of solution and accumulate as solid deposits. Over thousands of years, these deposits have built up layer upon layer, creating formations that mimic the appearance of cascading water while being entirely solid rock. The technical term is travertine, the same material that forms stalactites and stalagmites in caves, but here it occurs in open air, shaped by water that once flowed but has long since evaporated or been diverted. The effect is deeply surreal. Walking around the formations reveals how the mineralized water has created terraces and pools at various levels, some still holding water that appears milky from suspended minerals. The largest cascade drops roughly 50 meters down the cliff face, its surface rippled and textured like fabric caught in a breeze. Smaller formations branch off like tributaries, and in places, the travertine has formed delicate curtains and fins. The color varies from almost pure white to cream to ochre, depending on the specific mineral composition and the presence of algae and lichens that colonize the rock's surface. In morning or late afternoon light, the formations seem to glow, their pale surfaces standing out brilliantly against the darker cliff rock and the deep green of valley vegetation below. But Hierve el Agua is more than a geological curiosity. The site holds deep cultural significance for the Zapotec communities of the region. The springs themselves have been used for irrigation for at least 2,000 years. Archaeological evidence indicates that ancient peoples engineered a sophisticated system of canals and terraces to channel the spring water to agricultural fields. They understood the water's mineral content and worked with it rather than against it, creating farming systems that took advantage of the unique hydrology. The name Hierve el Agua translates roughly as the water boils, not because the water is hot, but because the springs bubble up from the earth, creating the appearance of boiling in the collection pools. For many local people, the springs retain spiritual significance. Water sources in arid or semi-arid environments are inherently precious, and springs that flow year-round become sacred places, sites where the earth offers sustenance. Traditional ceremonies and offerings still occur at Hierve el Agua, though now they share the space with tourists who come to photograph the petrified waterfalls. There's a tension in this sharing, as with many culturally significant natural sites that have become tourist destinations. Families who have lived in the nearby villages for generations now find themselves navigating relationships with visitors who may not understand the deeper meanings embedded in the landscape. The springs feed into shallow pools where people can swim or wade, surrounded by travertine formations that continue to grow incrementally. Sitting in these pools offers a strange sensation, knowing that the water gradually deposits minerals on everything it touches, including skin and clothing. The minerals are harmless, but leave a slight residue, a physical reminder of the chemical processes constantly at work. From the pools, the view extends across valleys where agave plants march in rows and where clouds often gather in the afternoons, sometimes obscuring the mountains, sometimes catching light in ways that make the sky itself seem like another geological wonder. The biodiversity of the Oaxacan highlands adds another layer to sites like Hierve el Agua. The region serves as a transition zone between temperate and tropical climates, creating habitats where species from both ecosystems mix and overlap. Birds unique to these elevations call from the scrubby vegetation clinging to the hillsides. Plants adapted to arid conditions grow alongside species that require more moisture, taking advantage of microclimates created by the terrain's complexity. The traditional agricultural practices of local communities, including milpa farming systems that integrate corn, beans, squash, and dozens of other plants, contribute to maintaining this biodiversity rather than diminishing it. There's wisdom in these practices, accumulated over centuries of close observation and transmitted through generations. Head north to the Yucatan Peninsula, and yet another stunning natural phenomenon awaits, this one involving color in an entirely different way. See, Las Coloradas sits on the northern coast of the peninsula, a remote area where shallow coastal lagoons have been converted into salt production ponds. The region's climate provides ideal conditions for solar salt production, with intense sun, low rainfall, and constant wind creating high evaporation rates. But what makes Las Coloradas extraordinary isn't the salt production itself, but rather the vivid pink color of the water in many of the ponds. A hue so saturated and unnatural-looking that photographs of the site often appear digitally manipulated. The pink isn't painted on or artificially created. It results from the presence of particular microorganisms, primarily a type of archaebacteria called halobacterium, and various species of algae, including Dunaliella salina, that thrive in extremely saline conditions. Yet as water evaporates from the ponds and salinity increases, these organisms proliferate. They produce carotenoid pigments as protection against the intense solar radiation. Carotenoids are the same compounds that make carrots orange and flamingos pink, and in the concentrated populations that develop in the hypersaline water, they tint the water itself in shades ranging from pale salmon to deep magenta depending on salinity levels, light conditions, and the specific species composition at any given time. Walking along the edges of these ponds feels like stepping into a dream where normal rules about color don't apply. One pond might shimmer in pale rose, while the adjacent one glows deep fuchsia. The contrast with the blue sky, the white salt crystals accumulating at the pond's edges, and the pale sand makes the pink appear even more intense. On calm days, the water's surface becomes mirror-like, reflecting clouds and creating disorienting compositions where sky and water merge in identical shades of pink. The salt workers who maintain the ponds and harvest the crystallized salt navigate this surreal landscape daily, though for them it's simply the workplace. the source of livelihood that connects them to a tradition of salt production stretching back to pre-Columbian times. The Yucatan coast has supplied salt for millennia. The Maya operated salt works in this region, and salt became a valuable trade commodity, transported inland to communities that had no direct access to the coast. Spanish colonial records document the importance of Yucatan salt, which was shipped throughout the Caribbean and beyond. And the traditional method of solar evaporation remains essentially unchanged from these earlier times. Shallow ponds are filled with seawater and left to evaporate. As water volume decreases, salt concentration increases until crystals begin to form and sink to the bottom. These crystals are then raked, collected, washed, and dried for use or sale. The pink water isn't present year-round or in all ponds. The color depends on achieving the right salinity and having the right conditions for the organisms to bloom. Typically, the most dramatic pink appears during the driest, hottest months when evaporation is most intense. As salt concentration increases toward the saturation point, the archaebacteria and algae reach their highest densities, and the color intensifies accordingly. Once salt is harvested from a pond and it's refilled with fresh seawater, the process begins again. The ecosystem of a salt pond is highly specialized, and the organisms that produce the pink coloration are extremophiles, life forms adapted to environmental conditions that would kill most other species. Las Coloradas sits within a larger protected area that includes Ria Lagartos Biosphere Reserve, recognized as an important wetland ecosystem and a critical habitat for numerous bird species. The mangrove forests, salt marshes, and shallow lagoons of this coastal region support one of the largest breeding colonies of American flamingos in the world. The flamingos themselves are pink for the same reason the water is. Carotenoids consumed through their diet of brine shrimp and algae accumulate in their feathers. Watching flamingos feed in the pink water creates a sort of chromatic harmony. Pink birds against pink water against blue sky, a natural palette that seems almost too coordinated to be real. The relationship between salt production and conservation in this area demonstrates how human activity and natural ecosystems can sometimes coexist beneficially. The salt ponds, while human-made, provide habitat for the same types of organisms that occur naturally in the region's hypersaline lagoons. The flamingos feed in both natural and artificial saltworks, and the shallow ponds offer protection from predators. Local communities have developed tourism initiatives that allow visitors to see both the salt production process and the flamingo colonies, generating income that supports conservation efforts while maintaining traditional salt working practices. There's recognition that the natural beauty of the place, including those surreal pink ponds, has value beyond the salt itself. The remoteness of Las Coloradas has helped protect it from overdevelopment. Getting there requires traversing roads that can be rough, passing through small fishing villages where boats outnumber cars, and where the rhythm of life follows tides and seasons. The air smells of salt and ocean. The light has a particular quality, intense and clear, sharpening every edge and saturating every color. In this environment, the pink ponds feel less like an anomaly and more like a natural extension of a landscape already characterized by extremes of heat, salt, and light. As the people who live here have adapted to these extremes just as the archaebacteria and flamingos have, finding ways to thrive in conditions that would challenge most organisms. These natural wonders, the shifting blues of Bacalar, the petrified cascades of Hierve el Agua, the pink ponds of Las Coloradas, share certain characteristics beyond their visual drama. They all result from water interacting with minerals in ways that produce unexpected colors and forms. They all exist in regions with deep indigenous heritage where traditional knowledge about place and ecology continues to inform how communities relate to the land, and they all challenge visitors to expand their understanding of what nature can create, to recognize that the surreal and improbable are, in fact, entirely natural phenomena arising from the complex chemistry and biology of Earth's systems. But Mexico's wonders aren't limited to natural formations shaped by water and minerals. The country is equally renowned for archaeological sites that stand as testaments to the ingenuity of ancient civilizations. Among these, Chichen Itza holds a place of special prominence, both for the scale and sophistication of its architecture, and for the astronomical knowledge embedded in its design. Located in the northern Yucatan, Chichen Itza was one of the largest Maya cities and served as a major political, economic, and religious center for centuries. The site sprawls across several square kilometers, encompassing pyramids, temples, ball courts, and administrative buildings arranged according to principles that reflect Maya cosmology and astronomical understanding. The most iconic structure, known as El Castillo, or the Temple of Kukulkan, rises from the center of a vast plaza, its 4 staircases ascending to a temple at the summit. Each staircase has 91 steps, and when combined with the temple platform at the top, they total 365, corresponding to the solar year. This numerical correspondence isn't coincidental, but intentional, one example among many of how Maya architects incorporated calendrical and astronomical data into their buildings. The Maya were sophisticated astronomers who tracked celestial movements with remarkable precision despite having no telescopes or other optical instruments. They observed the sun, moon, planets, and stars carefully over generations, recording cycles and patterns. They developed multiple interlocking calendars, including a ritual calendar of 260 days and a solar calendar of 365 days that meshed together in 52-year cycles. They could predict eclipses and the positions of Venus with accuracy. This astronomical knowledge wasn't merely academic, but integral to Maya religion, agriculture, and governance. The movements of celestial bodies indicated propitious times for planting, for warfare, for ceremonies, for crowning rulers. The cosmos and daily life were inseparable. At Chichen Itza, this integration of astronomy and architecture reaches extraordinary heights. El Castillo serves as a massive calendrical instrument, its proportions and orientations encoding temporal information. But the building's most famous astronomical feature appears only twice a year, during the spring and autumn equinoxes. As the sun descends toward the horizon on these dates, the angle of light creates shadows along the northern staircase that form a series of triangles. These triangles, combined with the carved serpent head at the base of the staircase, create the appearance of a serpent descending from the pyramid's summit. The effect lasts only a few hours, a fleeting display that draws thousands of visitors who gather to witness this ancient light show. The serpent is Kukulkan, the Maya name for the feathered serpent deity known elsewhere in Mesoamerica as Quetzalcoatl. This god held central importance in Maya religion, associated with wind, rain, learning, and the planet Venus. So the equinox phenomenon at El Castillo isn't accidental but deliberately engineered, requiring precise understanding of solar movements and sophisticated construction techniques. The architects knew exactly where to position staircase corners and how to angle balustrades so that equinoctial sunlight would create the desired effect. They built this knowledge into stone, creating a structure that functions as both temple and astronomical marker, demonstrating to all who witnessed it that the ruling elite possessed special understanding of cosmic forces. This melding of architecture with celestial observation extends throughout Chichen Itza, transforming the entire complex into a 3-dimensional calendar. The Temple of the Warriors stands aligned to capture specific stellar positions, its columns and friezes arranged to frame certain constellations at predetermined times. The caracol, often called the observatory, features windows positioned to track Venus through its complete cycle, allowing Maya astronomers to predict the planet's appearances with remarkable accuracy. They understood that Venus completed 5 cycles in almost exactly 8 Earth years, a mathematical relationship they incorporated into their calendar systems and used to schedule ceremonies and agricultural activities. Walking among these structures today, the precision becomes overwhelming. These weren't approximations or lucky guesses. The Maya had developed advanced mathematics, including the concept of zero independently from Old World civilizations, and used these tools to create astronomical tables that remain accurate millennia later. And they tracked not just the obvious movements of sun and moon, but the subtler patterns of planets, the 18-month cycle of lunar nodes, and the long-period alignments that occur only once in generations. At Chichen Itza, this knowledge became manifest in stone, creating a city that functioned as both urban center and cosmic map. The cenotes surrounding the city add another dimension to its sacred character. These natural sinkholes, formed when limestone bedrock collapses to reveal groundwater beneath, were considered portals to Xibalba, the underworld realm where gods and ancestors dwelled. The sacred cenote at Chichen Itza received offerings of precious objects, incense, and according to historical accounts, human sacrifices during times of drought or crisis. Modern archaeological diving expeditions have recovered hundreds of artifacts from its depths, including gold discs, jade ornaments, copper bells, and elaborately carved wooden objects preserved by the cenote's unique water chemistry. The relationship between cenotes and Maya civilization runs deeper than religion alone. In the Yucatan Peninsula's porous limestone terrain, these water sources were often the only reliable access to fresh water. Settlements grew around them, and their distribution influenced trade routes and territorial boundaries. Some cenotes form parts of vast underground river systems stretching for hundreds of kilometers beneath the jungle. The Maya understood this hidden hydrology, at recognizing connections between distant water sources, and using this knowledge to survive in an environment that appears lush but offers few surface streams or lakes. Traveling west from Chichen Itza toward the Gulf Coast, the landscape gradually transforms, and eventually you encounter a phenomenon so visually striking it seems almost fabricated. Near the small fishing village of Las Coloradas, shallow lagoons glow an intense bubblegum pink, their color so saturated and unnatural-looking that first-time visitors often assume digital manipulation in photographs. But this is no trick of lighting or camera filters. The water truly blazes this shocking shade of pink, a color so vivid it rivals any sunset maintained year-round under the tropical sun. So the explanation lies in extremophile microorganisms thriving in conditions that would kill most life forms. These lagoons contain salt concentrations sometimes exceeding 10 times that of seawater, creating an environment where only specially adapted bacteria and algae can survive. Particular species of halophilic microorganisms produce bright red carotenoid pigments to protect themselves from intense solar radiation. When these organisms bloom in sufficient numbers, they tint the entire water body pink, with color intensity varying based on salinity levels, temperature, and time of year. In the hottest, saltiest sections, the water can appear almost neon, a shade of pink that seems to violate natural color palettes. So these are not natural lagoons in the pristine sense, but part of an active salt production operation that has functioned for generations. Workers flood shallow pans with seawater, then allow the fierce Yucatan sun to evaporate the water, leaving behind crystallized salt. As water evaporates and salinity increases, the color deepens from pale rose to flamingo pink to deep magenta in the final evaporation ponds. The salt produced here supplies local markets and supports the regional economy, turning natural processes into livelihood while creating this surreal landscape as a byproduct. Walking along the earthen barriers separating different evaporation ponds reveals the gradation of color, each basin a slightly different shade depending on its stage in the production cycle. The contrast against the bright blue sky and white salt crystals accumulating along the edges creates a color combination that seems designed by an artist with a particularly bold palette. The pink water reflects and refracts light in unexpected ways, glowing luminously in afternoon sun, shifting toward purple tones near dusk, maintaining its unnatural vibrancy regardless of viewing angle or atmospheric conditions. The area also attracts flamingos, drawn by the same brine shrimp and other small organisms that contribute to the water's coloration. Seeing these pink birds standing in equally pink water creates a recursive effect, nature doubling down on a single improbable color. The flamingos feed on carotenoid-rich organisms, which in turn gives their feathers the characteristic pink hue, creating a closed loop where geology, microbiology, and ornithology all converge around this single vivid shade. Beyond Las Coloradas, Mexico's Caribbean coast presents a completely different aquatic palette. The region around Bacalar hosts a lagoon known as the Lake of Seven Colors, where water shifts through distinct bands of blue and turquoise depending on depth and bottom composition. Unlike the manufactured drama of the pink salt ponds, Bacalar's colors emerge from natural variations in the limestone floor and the crystalline clarity of the water itself. The lagoon stretches over 40 kilometers, connected to the Caribbean by a narrow channel, its fresh to brackish water fed by underground cenotes. The name Seven Colors understates the reality. Depending on where you look and how light strikes the surface, you might count dozens of distinct shades. From shallow areas over white sand bottom glow pale aquamarine, so light and bright they appear almost white in full sun. Slightly deeper sections turn to classic turquoise, the color of tropical vacation brochures. Where the bottom drops away or darker vegetation grows below, the water deepens to sapphire, then navy, then nearly black in the cenotes that puncture the lagoon floor. Areas with particular mineral deposits might show hints of green or gray, and the entire color map shifts throughout the day as the sun moves and clouds pass overhead. The water's exceptional clarity allows visibility of 10 meters or more in many areas, turning swimming or kayaking into a hovering sensation above intricate bottom landscapes. You can see fish moving through submerged vegetation, watch light playing across sand ripples, observe the exact point where fresh cenote water mixing with lagoon water creates visible boundaries in color and texture. Ancient Maya built settlements along these shores, and later pirates used the lagoon's complex geography and hidden channels to evade Spanish authorities, establishing Bacalar as a smuggling hub that thrived on its inaccessibility and the intimate local knowledge required to navigate its waters. Today, the lagoon faces environmental pressures from development and tourism. An invasive aquatic plant called hydrilla has spread through some areas, altering ecosystems and clouding previously crystal water. The famous stromatolites, living rock formations built by ancient bacteria similar to those that first oxygenated Earth's atmosphere billions of years ago, grow in Bacalar's shallows but face threats from boat traffic and pollution. These structures grow perhaps a millimeter per year, meaning the formations visible today represent thousands of years of bacterial construction. The ancient living monuments more vulnerable than they appear. Continuing south and west, crossing from Caribbean coast to Pacific, the geological character of Mexico transforms dramatically. The country sits atop multiple tectonic plates whose grinding interactions have built mountain ranges, spawned volcanic chains, and created the deep oceanic trenches offshore. This geology manifests in countless ways across the landscape, but few as visually dramatic as Hierve el Agua in Oaxaca, where frozen waterfalls cascade down mountainsides in complete defiance of their name. Hierve el Agua translates as the water boils, referring not to temperature, but to the bubbling springs that emerge from the mountaintop. These springs carry dissolved minerals, particularly calcium carbonate, leached from limestone formations deep underground. When the mineral-rich water reaches the surface and tumbles over the cliff edge, it begins depositing its dissolved cargo, gradually building up layers of travertine that harden into stone. Over thousands of years, this process has created massive petrified waterfalls, white and pale gold rock formations that look like frozen cascades, complete with ripples, flows, and splash patterns that mimic water's movement in permanent stone. The formations extend over 100 meters down the cliff face, curtains of stone following the exact paths that water would take if it fell freely. But the water doesn't fall, at least not in liquid form for long. It seeps down through the porous rock it has created, continuing to add new layers, infinitesimally expanding the formations with each passing year. The springs at the top still flow, creating natural infinity pools where water spills constantly over the edges, and brave swimmers can float right to the precipice and peer down the cliff face while warm mineral water flows around them. The white and amber coloring comes from different mineral compositions and varying amounts of iron oxide and other trace elements in the water. Some sections gleam nearly pure white, smooth and glossy, where water still flows regularly. Other areas show weathering and color variation, streaks of tan, orange, or gray, where different minerals predominated or where erosion has exposed older layers. The texture ranges from smooth as polished marble to rough and porous, depending on how quickly deposition occurred and what organisms or sediments got incorporated into the forming rock. Standing at the base and looking up, the scale becomes apparent. These are not small features, but geological formations comparable in size to actual waterfalls, tons of accumulated mineral deposits creating structures that will persist for ages, even if the springs eventually dry up. The surrounding valley spreads out in layered tones of green and brown, agricultural terraces and wild mountains, with these ghostly white cascades standing out like sculptures deliberately placed on the landscape. The springs themselves maintain a constant temperature, warm but not uncomfortably hot, rich with minerals that locals believe have therapeutic properties. People have bathed in these waters for centuries, perhaps millennia, though the site's current tourist infrastructure dates to recent decades. The water tastes slightly metallic, and noticeably different from regular drinking water, carrying the signature of its underground journey through limestone aquifers and volcanic rock. Similar travertine formations exist elsewhere in Mexico and around the world, but Hierve el Agua's combination of size, accessibility, and dramatic cliff-edge location makes it particularly striking. The formations continue to grow, imperceptibly to human observation, but measurably over years and decades. Scientists studying the site can calculate deposition rates and work backward to estimate how long the springs have been flowing, revealing that the oldest sections of these frozen falls may have begun forming over 50,000 years ago. The broader Oaxaca region contains exceptional cultural and natural diversity compressed into relatively small geographic area. The state encompasses Pacific coastline, high mountain ranges, broad agricultural valleys, cloud forests, and arid zones, each supporting distinct ecosystems and human communities. This topographic complexity created conditions where numerous indigenous groups developed in relative isolation, maintaining separate languages, traditions, and artistic styles that persist today, despite centuries of external pressure and cultural exchange. Oaxaca City itself centers around a zocalo, or main plaza, that serves as gathering point and social heart of the community. The stone buildings surrounding it date from colonial times, their thick walls and arcaded walkways providing shade and coolness even in midday heat. Markets spread through surrounding streets, selling textiles, pottery, carved wooden animals called alebrilles, and foods prepared from recipes passed through generations. The smell of roasting cacao, fresh tortillas, and smoking chilies fills certain streets, while others carry the scent of fresh flowers sold in enormous bundles for home altars and celebrations. The nearby archaeological site of Monte Alban occupies a mountaintop that was artificially flattened and expanded by the Zapotec civilization beginning around 500 BCE. The site covers multiple square kilometers with pyramids, ball courts, palaces, and residential areas arranged around a vast central plaza. The Zapotecs chose this location deliberately, a commanding position overlooking 3 valleys, easily defended but requiring enormous labor to construct. They hauled millions of stones up the mountain, created massive platforms by filling ravines with rubble and earth, and carved elaborate stone monuments, including the famous danzantes, stone slabs depicting human figures in twisted postures that may represent defeated enemies or ritual dancers. Monte Alban flourished for over 1,000 years before being gradually abandoned for reasons still debated by archaeologists. By the time the Spanish arrived in the 16th century, the site stood empty, its pyramids partially collapsed, its palaces silent. The Mixtec people who succeeded the Zapotecs as the region's dominant culture used Monte Alban as a necropolis, burying their nobility in tombs cut into earlier structures, surrounding the dead with elaborate offerings of gold, turquoise, jade, and carved bone. One tomb discovered in the 1930s contained treasures rivaling those of any ancient American culture: gold masks, necklaces of hundreds of jade beads, ceremonial knives with handles carved in intricate detail, breastplates made from thousands of shell pieces assembled into elaborate mosaics. These items now reside in museums, but they testify to sophisticated metalworking, lapidary, and artistic traditions that developed in this region. The Mixtecs created codices, accordion-folded books made from deer hide, recording histories and genealogies in pictographic writing that can still be partially read by specialists today. Only a handful of these pre-contact codices survived Spanish destruction, but they provide invaluable records of how these cultures understood time, power, and cosmic order. The traditions of fine metalwork, weaving, and pottery continue in Oaxaca's villages today. In Teotitlan del Valle, families maintain weaving practices going back centuries, creating textiles using backstrap looms and natural dyes extracted from local plants and insects. The most valued color, a deep red approaching purple, comes from cochineal, tiny insects that live on nopal cactuses. Harvesters collect the insects, dry them, and grind them into powder that produces this luxurious color, so valuable that colonial Spain exported cochineal as one of its most profitable American commodities, second only to silver. The process of creating these textiles involves entire families and can take months for complex pieces. First comes shearing wool from sheep, then washing, carding, and spinning it into thread. The thread must be dyed, often requiring multiple baths in different colors to achieve desired shades, with some colors requiring mordants or fixatives to make them permanent. Then the actual weaving begins, the weaver sitting for hours with the loom secured around her waist and anchored to a post or tree, throwing the shuttle back and forth, beating down each line of weft to create tight, durable fabric. Complex patterns require careful counting and planning, the weaver holding the entire design in memory or following patterns passed down through generations. San Bartolo Coyotepec became famous for its distinctive black pottery, so dark and glossy it looks almost like obsidian. The technique involves burnishing the clay before firing to compress the surface, then firing in a reducing atmosphere that turns the iron-rich clay deep black. Master potter Dona Rosa perfected the technique in the mid-20th century, and her descendants continue the tradition, creating everything from small decorative pieces to massive water storage jars. The pottery emerges from the kiln already black and shiny, requiring no glaze, its color and sheen created purely through manipulating the firing process. Different villages specialize in different crafts and different pottery styles. Some make green-glazed earthenware, others create delicate burnished pieces, still others focus on red clay cooking vessels designed for traditional recipes. This specialization creates regional markets where people from different villages exchange products, maintaining networks of trade and social connection that likely predate Spanish contact. Markets Day transforms town plazas into temporary bazaars where local farmers sell produce, craftspeople offer their work, and food vendors prepare regional specialties like tlayudas, enormous crispy tortillas topped with beans, cheese, and whatever seasonal ingredients are available. The cuisine of Oaxaca deserves its reputation as one of Mexico's most sophisticated regional cooking traditions. The 7 famous moles, complex sauces that might incorporate 30 or more ingredients including various chilies, spices, nuts, seeds, and chocolate, represent just one aspect of the culinary repertoire. Chapulines, toasted grasshoppers seasoned with garlic, lime, and salt, appear on many menus. Quesillo, the local string cheese, gets pulled into thin sheets and folded into tacos or melted over other dishes. Mezcal, the agave-based spirit native to this region, is sipped straight from small cups, each batch tasting distinctly of its particular agave species and the unique characteristics of the palanque or small distillery where it was made. Agave itself grows wild and cultivated across Oaxaca's landscapes, the spiky, succulent plants thriving in conditions too dry or poor for most crops. Different species grow in different ecological zones. Espadin, the most commonly cultivated variety, dominates lower elevations. Wild varieties like Tobala, Tepextate, and Jabali grow on mountain slopes and require 7 to 30 years to mature before harvesting. These wild agaves produce smaller quantities of liquid, but often carry more complex flavor profiles, with earthy, herbal, or fruity notes that distinguish them from cultivated varieties. Traditional mezcal production follows methods changed little in centuries. Harvesting requires skilled jimadors to identify ripe plants and hack away the sharp leaves to reveal the heart or pina. These hearts, sometimes weighing hundreds of pounds, are transported to palanques where they're roasted in underground pits lined with hot rocks and covered with earth. The roasting takes several days and imparts the characteristic smoky flavor to mezcal. After roasting, the softened pinas are crushed, traditionally using a stone wheel called a tahona pulled by horse or donkey in circles around a pit. The crushed agave goes into wooden or clay fermentation tanks, where wild yeasts convert sugars to alcohol over a week or two. Finally comes distillation, usually twice, in small copper or clay pot stills, where the master distiller using taste and experience to separate the desirable middle portion from the harsher heads and tails. The resulting spirit varies wildly depending on agave species, terroir, roasting method, fermentation time, and distiller's choices. Some mezcals taste aggressively smoky, others delicate and floral. Some carry distinct mineral notes from the soil where the agave grew. Others show fruit or spice characteristics. This diversity has sparked growing international appreciation for mezcal as a sophisticated spirit deserving the same attention given to fine wines or single malt whiskeys. The growing mezcal movement has brought renewed attention to Oaxaca's traditional communities, many of which have produced spirits using ancestral techniques for centuries. Small villages in remote mountain valleys now find themselves connected to global markets, their artisanal products sought by collectors and connoisseurs. This economic shift has complex implications. On one hand, it provides income and recognition for communities that have often been marginalized. On the other, it brings pressures of commercialization, questions about sustainability as demand grows, and the risk that traditional methods might be altered or lost in the rush to meet market expectations. Visiting a palenque, a traditional mezcal distillery, offers insight into how deeply this spirit connects to landscape and culture. These operations typically occupy rural settings where families have worked the same land for generations. The entire production process occurs outdoors or in simple structures open to the elements. Agave piñas arrive on wooden carts or the backs of mules. The conical earth ovens sit directly on the ground, their stones heated by wood gathered from nearby forests. Fermentation happens in wooden vats, often covered only with cloth or animal hides. The copper or clay stills sit over open flames, tended constantly during distillation runs that can last days. This intimate scale means every batch carries the mark of its maker and place. The maestro mezcalero makes countless decisions throughout production, drawing on knowledge accumulated through decades of practice and observation. When to harvest the agave, exactly how long to roast it, how much water to add during fermentation, when to make the cut during distillation that separates the heart of the run from heads and tails. Each choice influences the final character of the spirit. Many families guard their specific techniques as closely held secrets, passing them through bloodlines rather than teaching outsiders. The relationship between mezcal culture and the broader landscape of Oaxaca illustrates how Mexico's cultural heritage remains living and dynamic rather than preserved in museum display cases. These traditions continue because they maintain relevance and meaning for the communities that practice them. They adapt to changing circumstances while retaining core elements that connect present to past. The same pattern appears throughout Mexico in countless variations, in textile weaving, pottery making, traditional medicine, agricultural practices, and ceremonial observances. Moving from the valleys and mountains of Oaxaca toward Mexico's extensive coastlines reveals yet another dimension of the country's natural diversity. The transition zones where land meets sea create some of Mexico's most visually striking and ecologically significant environments. The Gulf of California, also known as the Sea of Cortez, separates the Baja California Peninsula from mainland Mexico, creating a marine environment so rich and varied that Jacques Cousteau called it the world's aquarium. The Gulf's unique geography and oceanography support an extraordinary concentration of marine life, from tiny endemic fish species to massive whale sharks and migrating gray whales. The coastline along the Gulf of California presents dramatic contrasts. Desert mountains plunge directly into deep blue water. Rocky cliffs give way to sandy beaches. Tidal ranges can be extreme, exposing vast areas of shoreline that teem with life during low tide. Islands dot the Gulf, each serving as critical habitat for seabirds, sea lions, and other species. The water itself shifts through a spectrum of colors depending on depth, bottom composition, and the angle of sunlight. From pale turquoise in shallow areas over sand, to deeper blue in open water, to nearly black where volcanic rocks line the shore. The biological productivity of the Gulf of California stems from several factors working in combination. The Gulf functions partially as an enclosed sea, with limited exchange with the Pacific Ocean occurring only at its southern end. This geography, combined with the Gulf's orientation and the surrounding desert topography, creates oceanographic conditions that bring nutrient-rich deeper water toward the surface. These nutrients fuel explosive growth of phytoplankton, which forms the base of a food web supporting everything from filter-feeding invertebrates to massive marine mammals. Certain locations along the Gulf have become renowned among naturalists and adventurers for their concentrations of wildlife. The northern Gulf's shallow waters serve as critical habitat for the vaquita, the world's smallest porpoise and one of the most endangered marine mammals. Despite extensive conservation efforts, the vaquita population has declined to perhaps fewer than 20 individuals, making every sighting precious and highlighting the fragility of even Mexico's most robust natural systems. Further south, the Midriff Islands, including Isla Tiburon, Mexico's largest island, create a complex of channels and passages where tidal currents concentrate nutrients and marine life. Waters around these islands erupt with activity during certain seasons. Massive schools of fish move through the channels, pursued by predators from all directions. From below, sea lions chase prey toward the surface. From above, seabirds dive into the churning water. The spectacle demonstrates the abundance possible in healthy marine ecosystems. The Pacific side of the Baja California Peninsula presents an entirely different coastal character. Here, the land faces open ocean, exposed to swells that have built over thousands of miles of unobstructed water. Rugged cliffs bear the scars of constant wave action, their faces carved into fantastic shapes by the relentless assault of water. In places, as the combination of wave action and geological structure has created blowholes where incoming swells force water and air through narrow openings in the rock, sending fountains of spray shooting skyward with a sound like cannon fire. Heading south along Mexico's Pacific coast, the landscape gradually transforms from the arid environments of Baja California to increasingly tropical conditions. The shift happens gradually, marked by the appearance of new plant species, changes in rainfall patterns, and alterations in coastal ecology. By the time you reach the states of Nayarit and Jalisco, the vegetation has become lush, beaches are backed by dense forest rather than desert, and the climate follows distinct wet and dry seasons rather than the near-constant aridity of the far north. And this stretch of Pacific coastline includes some of Mexico's most famous beach destinations, but also preserves areas of remarkable natural value. The Islas Marietas, a group of small islands in Banderas Bay, gained international attention due to a hidden beach, a circular opening in the top of a collapsed cave that creates a secluded beach accessible only through a water tunnel at low tide. The formation itself demonstrates the power of wave action combined with geological processes over time. The islands support breeding colonies of seabirds and represent important protected habitat, despite their proximity to major tourist areas. Further south, the coast of Oaxaca presents a different rhythm. Long stretches of undeveloped coastline separate small fishing villages and emerging beach towns. The beaches here range from broad expanses of golden sand to rocky coves accessible only by foot or boat. During winter months, gray whales migrate past this coast on their way between feeding grounds in the Arctic and breeding lagoons in Baja California. Dolphins frequently swim close to shore. Sea turtles nest on certain beaches, their arrival timed by ancient instinct to the seasons and conditions that maximize their offspring's chances of survival. Several species of sea turtles nest along Mexico's Pacific coast, including the olive ridley, leatherback, and hawksbill. Each species follows its own pattern, but all share the basic behavior of females returning to beaches to dig nests, deposit eggs, and return to the ocean, leaving the eggs to incubate in the warm sand. In some locations, these arrivals occur as synchronized mass nesting events called arribadas, when hundreds or thousands of females come ashore simultaneously over a period of several days. The beach becomes a churning mass of activity as turtles excavate nests, lay eggs, cover the nests, and make their way back to the water. The biological and evolutionary reasons for this synchronized behavior remain subjects of scientific study and debate. The relationship between coastal communities and sea turtles illustrates another aspect of how Mexico's cultural and natural elements intertwine. Historically, many coastal communities harvested turtle eggs and meat as food sources, as turtle populations declined globally due to overharvesting, habitat loss, and other pressures. Conservation efforts sought to protect remaining populations. This created tensions between conservation goals and traditional practices. Over time, many communities have become active participants in turtle conservation, with locals working as nest monitors, patrolling beaches during nesting season, protecting eggs from poaching, and educating visitors. This shift represents neither simple preservation of tradition nor wholesale adoption of outside conservation models, but rather an evolution that incorporates elements of both. Mexico's Caribbean coast presents yet another distinct coastal environment. The Yucatan Peninsula's eastern shore faces the Caribbean Sea, and the presence of the Mesoamerican Barrier Reef System, the second longest coral reef system in the world, defines much of the marine ecology. The reef parallels the coast from the northern tip of the peninsula southward past Belize. This massive structure, built slowly by coral polyps over millennia, creates habitat for an extraordinary diversity of marine life and provides crucial coastal protection by absorbing wave energy before it reaches shore. The waters of the Mexican Caribbean display the archetypal tropical blue-green color that defines paradise in popular imagination. This distinctive color results from several factors: the purity of the water with relatively little suspended sediment, the white sand bottom that reflects light, the shallow depths that allow sunlight to penetrate, and the way water molecules scatter light. The color shifts with depth and distance from shore, creating gradients from pale turquoise over sandflats to deeper blue over reef areas to dark blue in the open water beyond the reef. Beneath the surface, the reef system supports one of the planet's most complex and biodiverse ecosystems. Coral formations create three-dimensional structures that provide habitat for countless species. Fish of every imaginable color, pattern, and body shape move through the coral heads and along the reef face. Invertebrates filter water, hunt prey, or simply wait attached to substrate. Sea turtles glide past, pausing to feed on seagrasses or to rest in protected areas. Larger predators cruise the reef's outer edge, where the shallow reef drops away into deeper water. The health of coral reefs has become a major concern globally, and Mexico's Caribbean reefs face multiple stressors. Rising water temperatures can cause coral bleaching, a stress response in which corals expel the symbiotic algae that give them color and provide much of their nutrition. Repeated or prolonged bleaching events can kill coral colonies that took decades or centuries to grow. Pollution from coastal development and agriculture introduces nutrients that can shift reef ecology in harmful ways. Physical damage from boat anchors, careless divers, or storms can break fragile coral structures. Disease outbreaks have devastated certain coral species. These pressures compound each other, creating challenges that require coordinated responses from governments, scientists, local communities, and the tourism industry that depends on healthy reefs. The Sian-Ka'an Biosphere Reserve, south of the resort area of Tulum, protects a large section of coast and inland areas, encompassing diverse habitats from coastal reef and mangrove forests to inland wetlands and tropical forest. The reserve's name comes from Mayan language and translates roughly as origin of the sky, or place where the sky is born, reflecting the area's significance to Maya culture. The reserve serves multiple functions simultaneously, protecting biodiversity, preserving archaeological sites, supporting traditional livelihoods of local communities, and providing opportunities for low-impact tourism and research. Exploring Sian-Ka'an reveals the interconnections between seemingly separate habitats. Mangrove forests along the coast provide nursery habitat for many fish species that will later move to the reef. They also trap sediment and filter water before it reaches the ocean. The inland wetlands store water during the rainy season and release it gradually during dry periods. The forests provide habitat for land animals, while their root systems help prevent erosion. These connections mean that protecting the reserve requires managing it as an integrated whole rather than as separate units. The reserve also protects numerous Maya archaeological sites, most much smaller and less visited than famous sites like Chichen Itza or Tulum. These ruins remind visitors that the pristine wilderness concept often proves misleading when applied to places like the Yucatan Peninsula. The Maya civilization profoundly influenced this landscape for thousands of years. They modified forests through selective harvesting and cultivation. They built cities, roads, and agricultural systems. And they managed water resources through elaborate systems of modified natural features. The forests and ecosystems that exist today developed under this human influence. Understanding this history complicates simplistic narratives about nature and culture as separate realms. The cenotes scattered throughout the Yucatan Peninsula represent another example of natural features that hold both geological interest and deep cultural significance. These sinkholes, formed as rainwater, slowly dissolved the limestone bedrock over millions of years. The slightly acidic rainwater reacts with calcium carbonate in the limestone, gradually enlarging cracks and hollow spaces. When underground chambers grow large enough, their roofs eventually collapse, creating openings to the surface. As the result ranges from small holes barely large enough for a person to enter to vast open pools more than 100 meters across. The Maya considered cenotes sacred places, portals to the underworld in their cosmological understanding. Many cenotes contain evidence of ceremonial use, offerings of pottery, jewelry, and other valuables thrown into the water as gifts to the gods. Some cenotes contain human remains, evidence of sacrifice performed as part of religious ritual. The cenotes also provided crucial access to fresh water in a landscape where surface water is generally scarce. Most rainfall quickly percolates through the porous limestone rather than forming rivers or lakes. The cenotes allowed communities to access the groundwater table, making permanent settlement possible across the peninsula. Today, cenotes attract visitors for different reasons, though elements of reverence remain. Many have been developed for swimming or diving, with stairs, platforms, and facilities added to make access easier and safer. Others remain wild, requiring rappelling down ropes to reach the water. Diving in cenotes offers experiences unlike any other form of underwater exploration. The water clarity often exceeds 50 meters of visibility. Shafts of sunlight penetrate the openings from above, creating dramatic light effects. In deeper passages beyond natural light, formations of stalactites and stalagmites create otherworldly landscapes. Some cave systems extend for many kilometers underground, connecting multiple cenotes through flooded tunnels. The environmental conditions within cenotes support unique ecosystems adapted to permanent darkness and relatively stable conditions. Certain fish species found in cenote systems exist nowhere else. Blind cavefish have evolved to navigate and feed in total darkness. Bacteria and other microorganisms form the base of food webs that function without photosynthesis. Scientists continue discovering new species in these underground environments, suggesting that much remains unknown about the biological diversity they harbor. As with many of Mexico's natural and cultural treasures, cenotes face challenges from human activity. Increased tourism brings both economic benefits and environmental pressures. Swimmers wearing sunscreen introduce chemicals into these closed aquatic systems. Increased foot traffic can damage formations that took millennia to develop. Poorly managed development in areas above cenotes can introduce pollutants into the groundwater. Since the underground water systems connect across large areas, contamination in one location can spread throughout the aquifer. Balancing access and protection requires ongoing attention and adaptive management. Returning north from the Yucatan Peninsula toward central Mexico, the landscape rises from coastal plains to the high central plateau that forms the country's geographic heart. This vast elevated region, sitting between Mexico's two major mountain ranges, holds the majority of the country's population and its largest cities. Yet even here, surrounded by urban development and intensive agriculture, striking natural and archaeological sites persist, often in unexpected proximity to dense human settlement. The Valley of Mexico, a high-altitude basin surrounded by mountains, contains Mexico City and its sprawling metropolitan area. The modern megalopolis obscures the fact that this valley once held a system of interconnected lakes. The Aztec capital of Tenochtitlan was built on islands in the largest of these lakes, connected to the shore by massive causeways. Spanish conquistadors who first saw the city described it as one of the wonders of the world, comparable to Constantinople or Venice. The lake setting provided defense, transportation, and a foundation for the Chinampa agricultural system, artificial islands built from layers of vegetation and mud where crops could be grown with remarkable productivity. Over centuries following the Spanish conquest, the lakes were gradually drained to provide land for the expanding city and to control flooding. Today, only fragments remain. Xochimilco, in the southern part of the metropolitan area, preserves the last significant remnant of the Chinampa system. Here, narrow canals separate long rectangular islands where vegetables and flowers still grow using methods that trace back centuries. Colorful boats called trajineras carry visitors through the canals, past chinampas, and through neighborhoods that maintain traditions despite being surrounded by one of the world's largest cities. Xochimilco also harbors one of the planet's most unusual and endangered amphibians, The axolotl, a type of salamander that retains its larval form throughout its life, once lived throughout the Valley of Mexico's lake system. As the lakes were drained and urbanization intensified, axolotl populations crashed. Today, wild axolotls survive only in the Xochimilco canals, and even there their numbers have declined to critically low levels. The species survives primarily because it breeds easily in captivity and has become widely used in scientific research due to its remarkable ability to regenerate lost body parts. Yet, the persistence of wild populations remains uncertain, their fate tied to the preservation of their remaining habitat. Not far from Mexico City, the archaeological site of Teotihuacan presents one of ancient Mesoamerica's greatest achievements. The city reached its peak around 450 CE, when it housed perhaps 100,000 people or more, making it one of the largest cities in the world at that time. The site's layout follows a precise plan aligned with astronomical observations. The main avenue, misleadingly called the Avenue of the Dead by later visitors, runs roughly north-south and connects the major pyramids and temple complexes. The Pyramid of the Sun, one of the largest structures built in the pre-Columbian Americas, rises over 60 meters. Its massive bulk required millions of cubic meters of earth and stone, representing an enormous investment of labor and resources. Climbing the steep stairs to the top of the Pyramid of the Sun offers perspective on both the site's scale and its geographic setting. The pyramid and surrounding structures spread across a wide valley floor, backed by mountains on multiple sides. From above, the precision of the city's layout becomes apparent. The careful alignment of structures, the consistent spacing, the integration of residential areas with monumental architecture. On clear days, which are increasingly rare given Mexico City's air quality issues, the distant volcanic peaks of Popocatépetl and Iztaccíhuatl rise to the southeast, their snow-capped summits gleaming. The identity and fate of Teotihuacan's builders remain subjects of debate and ongoing research. Unlike later civilizations like the Aztecs, Teotihuacan left no written records that have been definitively deciphered. The city was already ancient and long abandoned when the Aztecs rose to power centuries later. The Aztecs revered the ruins, incorporated them into their own mythology, and gave them the names by which they're still known. But who actually built Teotihuacan? What language they spoke? How their society was organized? And why the city was ultimately abandoned remain incompletely understood despite decades of archaeological investigation. Recent research using technologies like LiDAR and ground-penetrating radar has revealed previously unknown structures and details at Teotihuacan and many other Mexican archaeological sites. These techniques allow researchers to detect features beneath vegetation or soil without excavation. At sites across Mexico, these new tools have shown that what was visible on the surface represented only a fraction of what existed. Entire complexes of structures, agricultural terraces, roads, and water management systems have been detected, fundamentally changing understanding of how large and complex these ancient cities and their supporting landscapes actually were. The active volcanoes that rise southeast of Mexico City remind us that Mexico sits in a geologically dynamic zone where tectonic plates interact. The Trans-Mexican Volcanic Belt, a chain of volcanoes stretching across the country's midsection, results from the subduction of the Cocos Plate beneath the North American Plate. This ongoing geological process generates the magma that feeds Mexico's volcanoes and causes the earthquakes that periodically shake the region. The volcanic peaks that define Mexico City's skyline on clear days represent both the beauty and danger inherent in the country's geological setting. Popocatépetl, called simply Popo by locals, remains active and regularly emits steam and ash from its summit crater. The name comes from Nahuatl, the language of the Aztecs. Cheyenne translates roughly as smoking mountain. Its neighbor, Iztaccíhuatl, is currently dormant. Its profile, viewed from certain angles, resembles a reclining woman, giving rise to its name meaning white woman, and the legend that connects the two peaks. According to one version of the story, Iztaccíhuatl was a princess whose warrior lover Popocatépetl went to war. When false reports of his death reached her, she died of grief. When he returned and learned of her death, he carried her body to the mountains where they were transformed into the two volcanoes, one sleeping and one keeping eternal watch. These legends, like countless others throughout Mexico, illustrate how human imagination has always worked to explain and find meaning in the landscape. Mountains become gods or transformed lovers. Cenotes become portals to other realms. Unusual rock formations become the petrified remains of giants or spirits. These stories represent different ways of knowing the land, complementing scientific understanding with narratives that embed landscape within systems of meaning and relationship. Mexico's extraordinary natural and cultural heritage faces pressures from many directions: population growth, urbanization, climate change, economic development, tourism, and countless other forces that characterize the contemporary world. Yet the country also demonstrates how heritage can be maintained and adapted through changing circumstances. Ancient cities become protected archaeological zones. Traditional practices find new economic viability. Natural areas become reserves that serve multiple purposes simultaneously. None of these solutions are perfect or permanent, and all require constant negotiation between competing interests and values. What emerges from encountering Mexico's diverse landscapes and heritage sites is recognition of the country's remarkable depth. Every landscape holds layers of meaning and history. Every archaeological site connects to living cultural traditions. Every natural feature has been experienced, named, and incorporated into human understanding across thousands of years. This depth resists simple characterization or easy summary. It demands patient attention and willingness to see beyond initial impressions. The places described here represent only a small sample of what Mexico contains. Each region has its own character, its own particular combinations of geology, climate, ecology, history, and culture. While the copper canyons of the northern mountains hold their own secrets. The cloud forests of Veracruz harbor species found nowhere else. The beaches of the Pacific coast witness annual migrations and gatherings of marine life. The archaeological sites of Chiapas preserve sculptures and hieroglyphs that continue revealing information about Maya civilization. Every corner of the country rewards exploration with discoveries both expected and surprising. For those who visit Mexico's natural and archaeological sites, the experience can fundamentally shift perspective on what places can be and mean. These locations demonstrate that nature and culture cannot be separated into neat categories, that landscapes bear the marks of millennia of human presence, that ancient accomplishments remain relevant and impressive by any standard. That beauty takes countless forms, and that the relationship between people and place continues evolving. Mexico invites us to look carefully, to question assumptions, to appreciate complexity, and to recognize that wonder remains available to those willing to seek it out.